The incircle of a triangle is a circle that's tangent to all three sides of the triangle. Another name for incircle is inscribed circle. Okay, let's see an example. Here's a triangle and let's draw its incircle. An incircle is the largest circle you can draw inside a triangle, and as you can see, it's tangent to all three sides, touching each side at exactly one point. So next, take a look at these circles. Which of them appear to be incircles of their triangles? Right, these are examples of incircles. Now suppose you have a triangle with side lengths A, B, and C, and suppose the area of this triangle is K. Let's draw the incircle and suppose it has radius R. In this lesson, we'll be asking the following question. How can we calculate the radius of the incircle, or the inradius? In other words, given A, B, C, and K, can we come up with an expression for R? Let's find out. First, let's draw radii to each side of the triangle. And remember that radii are perpendicular to their tangent lines, so we have right angles here. And let's also draw line segments between the center of the incircle and the triangle's three vertices. Now take a look at this smaller triangle here, whose base has a length A and whose height is R. What's the area of this triangle in terms of R and A? Excellent! So the area of this smaller triangle is 1/2 RA. Next, take a look at this triangle on the left. It has a base of length B and a height of R. So what's the area of this triangle? Precisely, the area of this triangle is 1/2 RB. Finally, take a look at this triangle over here. Its base has length C and its height is, once again, R. So what's the area of this triangle? Precisely, so this triangle has an area of 1/2 RC. So now that you've found the areas of all three parts of the larger triangle, we can now come up with another expression for the area K. K, the area of the larger triangle, must be equal to 1/2 RA plus 1/2 RB plus 1/2 RC. In other words, the area of the big triangle equals the sum of the areas of the three smaller triangles. Now notice that each of these terms has a 1/2 R in it, so we can factor out 1/2 R, meaning this expression equals 1/2 R times A plus B plus C in parentheses. Now remember, we wanted to find an expression for the inradius R in terms of A, B, C, and K. So let's solve this equation for R. So first, let's multiply both sides by 2. On the left, we now have 2K, and on the right, the 2 and the 1/2 cancel out. Finally, let's divide both sides by A plus B plus C. So here's the answer. For any triangle, the radius of the incircle always equals 2 times the area divided by the perimeter, the sum of the three sides of the triangle. That's a pretty elegant formula, right? So let's try a practice problem. Here's a right triangle with side lengths 6, 8, and 10, and here's the incircle for this triangle. What's the inradius? That is, what's the radius of this incircle? If you get stuck, feel free to ask for a hint. Exactly, you can use this formula for the inradius. The area of this triangle is 1/2 times 6 times 8, or 24, and the perimeter is 6 plus 8 plus 10, which also equals 24. The 24s cancel out, leaving you with 2, and that's the radius for this incircle. It's 2. Let's try one more example. Here's an isosceles triangle with one side of length 10 and two sides of length 13. What's the radius of this triangle's incircle? There are a few different ways to figure this out, and if you get stuck, just click down here. Okay, no problem. Now the first step in calculating the inradius is to find the triangle's area. So what's the area of this triangle here? Well, one way to find the area is with Heron's formula. the square root of the semiperimeter S times S minus A times S minus B times S minus C. Heron's formula will definitely give you the correct area, but let's see if we can find this triangle's area another way. Let's draw an altitude to the side of length 10. Because this is an isosceles triangle, the altitude also bisects the base, so each half has a length of 5. Now take a look at this half of the triangle over here. It's a right triangle with hypotenuse 13 and a leg of length 5. How long is the other leg? In other words, what's the height of this triangle? Exactly, this is a 5, 12, 13 right triangle. So for our larger triangle, the height is 12 and the base is 10. So what's the area of this entire triangle? Right, so the area is 1/2 times 10 times 12, or 60. So now that you know the triangle's area, try using this formula to calculate the radius of this triangle's incircle. Nicely done. So using this formula, the area of the triangle is 60 and the perimeter is 13 plus 13 plus 10, or 36. 2 times 60 is 120, so this expression equals 120 over 36, which simplifies to 10/3. And that's the radius of the incircle. So remember, to find the radius of a triangle's incircle, you can double the triangle's area and then divide by the perimeter. Again, nicely done.